Hi guys, this is part 3 of the section 8.2 lesson 3x3 systems. Today we're just going to practice a little bit more with our word problems, setting them up and solving. Let's start with the first one. A college algebra class of 38 students at Central State College is made up of people who are 18, 19, and 20 years old. The average of their ages was 18 and a half years. How many of each age were in the class? That's supposed to say if the number of 18-year-olds was 8 more than the combined number of 19 and 20-year-olds. In this example, our variables are X, Y, and Z we're just going to use. So the number of 18-year-olds, 19-year-olds, and 20-year-olds. Normally I like to pick a variable that represents whatever we're solving for, but because they're a set of ages of students, I think X, Y, and Z will work fine. I'm just going to label at the top here where I see 18 and 19 and 20, X, Y, and Z, so at the end I remember what's what if I have to label it. All right, so because we have 3 variables, we need 3 equations. The first piece of information I was given, a college algebra class of 38 students, was made up of 18, 19, and 20-year-olds. So that 38 is a total, and its number of students, which is what our X, our Y, and our Z stand for. So that's equation number 1. The next thing I was given was the average of their ages was 18 and a half years. So in this equation, we're going to set up an average, and we know the average is equal to 18 and a half, so I'll set up that part. You have to be careful here. We're going to add up every student's age and divide by how many students there are. Well, we already know from the last piece of information that there are 38 students total. So that means whatever I see on the top, there should be 38 items. So I don't just want to say X plus Y plus Z because that's just how many of each age I have. We want the top to represent everyone's age individually. So let's say, for example, I have 3 18-year-olds. I would have 3 X's that would be in this numerator. Or if I have 5 19-year-olds, I would have 5 Y's that go in the numerator. So in general, we could say that we have X 18-year-olds, we have Y 19-year-olds, and we have Z, if I can squeeze it in there, 20-year-olds. And that's a nice way to condense that. Dividing by, we know there are 38 students total, gives me an average of 18 and a half. The last piece of information we were given was that the number of 18-year-olds, which is X, was 8 more than the number of 19 and 20-year-olds. So if I take my number of 19 and 20-year-olds, oops, I don't want a 19 there, I just want my Y. Let's erase that. If I take my number of 19 and 20-year-olds, add them together, plus an additional 8, we will have the number of 18-year-olds. Whenever you see more than and less than, these are tricky. Some people will want to, when they set up this equation, say X plus 8 equals Y plus Z, but that means the opposite of what we're actually seeing in this statement. We want the 18-year-olds to be more than the 19 and 20-year-olds, so the 8 gets added on to the 19 and 20-year-olds. All right, now solving this system, the first equation looks good. The second equation, I don't want that denominator there, so I'm going to multiply both sides by 38. On the left, the 38s are just going to cancel, so I'm going to have an 18x, a 19y, a 20z, and let me just get rid of my calculator there. Let me see if I can delete it. Give myself some room. There we go. Equals whatever 18 and a half times 38 is. I'll type that in my calculator. And I get 703 is all of my ages of all of my students added together. I'll bring over my X plus Y plus Z. And then in the bottom equation, I just want all my variables on the same side. So let's move the Y and the Z over to the left. So it'll be a minus Y, a minus Z, and it will equal 8. Now we're ready to solve my system. I've got everything in standard form. Let's say I decide I want to get rid of my y's because I already have a positive y and a negative y. I'm going to pair up my first equation with my third equation to start here. So my first equation, x plus y plus z equals 38. And my last equation was x minus y minus z equals 8. And we're all set to add these together. I'll get a 2x. My y's will cancel. My z's will cancel. I'll get a 46. Divide by 2. I get x is 23. I can plug in x is 23, but then in all of my equations, I still have a y and a z. So we need to again go back to my original equations and pair up another set. So let's say I pair up equation 2 with equation 3. Equation 2 is 18x plus 19y plus 20z equals 703. And my bottom equation is x minus y minus z equals 8. Again, remember we want those y's to cancel. So I'm going to multiply the bottom by 19. That'll give me 19x, negative 19y, negative 19z, and then 8 times 19. Again, I'll pop that one in my calculator, 152. Add my equations together. I'm going to have a 37x. My y's cancel. I'll have a z left. And then I have 703 plus 152 on the other side, which is going to give me 855. At this point now, I can take that 23 that I knew and plug it into that second equation. So 37 times 23 plus z equals 855. 37 times 23 is going to give me 851 plus z equals 855. Subtract my 851 over, I'm going to get z is 4. And then all I'm missing now is my y. I can go back to my original equation, x plus y plus z. X is 23, y I don't know, z is 4, my total is 38. So I have 27 plus y is 38, and I get y is 11, which then you could check all three of those values back in the original problems and make sure they work. You would also probably want to label these at the end. So we have 23 18-year-olds, 11 19-year-olds, and 4 20-year-olds. The nice thing about a problem like this is you know x, y, and z stand for amount of something. So you should expect nice, pretty positive whole numbers here. If for some reason you got a fraction or a decimal or a negative, you would know that that answer doesn't make sense. So you would know to go back and check your work. Okay, we're only going to do one more word problem in this lesson. In this one, Miguel invested $20,000 in 3 different funds that paid 4%, 5%, and 6% for the year. The total income from the year for the 3 funds was $1,060. The income from the 6% fund was twice the income from the 5% fund. How much was invested in each fund? Again, we don't have great variables to choose from here, so I'm just going to use x, y, and z. I'm going to use x. I can get it up there. Let's see if this is going to right. There we go. X for the 4%, y for the 5%, and z for the 6%. X, y, and z here represent the amount that he's putting in each account. So we know total, if he invested $20,000, the amount he puts in each account added together will give me 20,000. And there's our first equation. The second sentence talks about the total income received. The total income was $1,060. So again, that total is going to go all by itself in my equation. And to calculate an income based on an amount invested, you're going to take your interest rate. So we'll start with 4%, 0.04, and multiply it by the amount that you invest. So 4% of x, whatever x is, will be the amount that he's getting from that 4% account, that first account. And 5%, he invested y, and at 6%, he invested Z, and all three of those investments total brought him $1,060. Finally, the income from the 6% fund, which is Z, was twice the income from the 5% fund. So again, this is another tricky one, more than, less than, twice, triple, that sort of thing. The 6% fund, you want to remember here, is more than the 5% fund. So we're taking 2 times my 5% fund, Y. And now we have our three equations. Again, I'm going to move some things around here to make this a little bit nicer. I'm going to keep my top equation the same. The equation in the middle, I'm going to multiply by 100 to move those decimals 2 spaces over. That's going to give me a 4x, a 5y, a 6z, and it's going to give me a couple extra zeros on my 1060. And then the equation at the bottom, I'm just going to move my 2y over and make it a negative 2y plus z, and there'll be nothing on the other side, so that's a 0. So there's my system. Notice the bottom equation is missing an x, so if you're solving here, you probably want to get rid of the x's, which means the next step you won't have much of a choice with. You're going to pair up equation 1 with equation 2, and you're going to remove the x's. I'm going to multiply the top equation by negative 4. So I'll have a negative 4x, a negative 4y, a negative 4z, and then I will have a negative 80,000. From there, I can add my equations together. X's cancel. Y's will give me a 1y. Z's will give me a 2z. And on the other side, I have 106,000. And then I'm adding a negative 80,000, which is going to give me 26,000. We'll call that equation 4. Equation 4 and equation 3 now both have the same 2 variables. So at this point, I can combine them together. Let's do that. Equation 3, negative 2y plus z equals 0. And equation 4, y plus 2z equals 26,000. I'm going to multiply, let's see, the top equation by negative 2. I don't want to multiply the bottom equation here because those numbers are just getting a little big. I don't want to make it crazy. Top by negative 2 is going to give me a 4y, a negative 2z, and again a 0. Add those equations together. I'm going to have a 5y equals 26,000. And then divide by 5. Y is 5,200. So that's the amount we're investing at 5%, $5,200. From there, you can start plugging that back in. Let's say I go back to equation 3 now. Negative 2 times 5,200 plus z is 0. 5,200 times 2 gives me 10,400, so negative 10,400 plus z equals 0. And if I move that over, I'll get z equals 10,400. So that's the amount we're investing in the 6% account. And then finally, we're going to go back to our original equations. We know x plus y plus z is 20,000. So x, whatever that is, plus 5,200 plus 10,400 is 20,000. Subtract 5,200 and 10,400 to the other side. And that's going to give me a grand total of 4,400 is invested at a 4% interest rate. So again, if you were writing this on a test or a quiz or homework, you'd want to make sure you label these. So 4,400 is invested at a 4% interest rate. 5,200 is invested at the 5% interest rate. and $10,400 is invested at the 6% interest rate. And you can always plug those back in to make sure they work in the equations you've written. All right, that will wrap up our 8.2 lesson. The Math Excel assignment is due on September 7th at 11:59 p.m.